Kids. All right. Hey, yesterday you built a real basic circuit with a capacitor and a light bulb and a battery eliminator, so you could see kind of what a capacitor actually does, how it works. So I want to make sure that it makes sense. I'm doing it this way just so you guys can kind of all go at your own pace and rewind and stop and take some notes and do whatever you want. But if you guys take a look at the very beginning, so this is the instant you turn your battery eliminator on, okay? I want to talk about what was on this capacitor. Remember, a capacitor, two parallel plates, maybe something in between, maybe it's not. But the instant you turn it on, well, this thing was uncharged. It was neutral. Well, then you know what? This capacitor, the instant you turn it on, is going to act just like a wire. Okay, it might as well be just a circuit with a wire here, just for that first instant. Why? Well, there's no charge on these plates to make it to like push against the current at all. Well, if that's going to be the case, well then I just get current to flow. So that would be my initial current. Okay, so the instant you turn your capacitor on, it's going to be like, hey, it's going to act like a wire. Okay. Well, and then over time, and remember, if you guys remember, let me make sure you can see this. Remember, this was our, you can think back to this graph, and we're going to be talking about that graph quite a bit. But if you think back to that graph, so over time, your charge builds up on this capacitor. Hey, look, I'm going to start getting remember, this is your positive, that's your negative. I'm going to start building a positive charge on this side, which means it's one positive charge get deposited on here, it pushes a positive charge off, and it goes around like this. I am going to be talking about positive charge moving, which is okay. Okay, it's not okay to say protons are moving. In reality, electrons are going the other way. So if I say, hey, a positive charge gets pushed onto this plate, which pushes the positive charge off. In reality, an electron is just going the other way. Why are we doing this? Because conventional current is the direction of positive charge. So that's why. So that's why I'm going to be talking like that. But so what happens, you can think, remember these wires are all full of charge. So it's push. They push a positive charge, and then one positive charge pushes onto this plate. Okay? Which then pushes, you know what? It pushes one of the positive charges off of this plate. And the positive charge gets push. So now this has a positive charge, this has a negative charge. So you know what? In my graph, I'm moving a little bit up this way, okay? Then that continues. I get another positive charge. It pushes off another positive charge. So I'm moving this way just a little bit more. And this continues, and it continues, and it continues, and it continues. Until eventually what happens is, and I want to make sure you understand, as this is building up a positive charge, it's making it harder for the positives to move around. Why? Because it's like, well, this one's trying to push this one, it's trying to push this one, and so on. And then when it gets to the plate, well, you know what? There's already all kinds of positive charge there. So it's like, I can't go. So eventually what happens is so much positive charge, so much charge builds up on your capacitor that no more positive charge can build up. Why? Because if you do your loop rule, the voltage here is going to be equal to the voltage here, and that's when your light bulb completely turned off. Why? Because there is no current. So it's like, hey, you reach a point where you're going up your graph until you get to this, and that was, can you guys see that? That was the battery voltage. Because, hey, you know what? If this is equal to the battery voltage, then the voltage across here, because if I do my loop rule around, has to be, with this voltage would have to be 0, so there's no current, and there you go. Okay. Hopefully that first piece makes sense as far as the charging up, how it actually charges. The other thing that you guys can think about if it helps, as far as what's happening across here, is that you can think as that charge is building up on the plates, you could think of it like in terms of our V equals ED equation. Well, as I build up charge, I'm not doing anything to the distance, that's staying the same. But as I build up charge, you can think, each time I'm building up charge, I'm getting more electric field between there. The electric field is increasing. As the charge goes up, well, if this is the same, this goes up, my voltage has to go up, which is why that's really what's happening in terms of this equation. So two different ways you can interpret it. So hopefully that helps as far as the charging piece. See you soon, kids.